welcome to the Tart channel. Tart stands for Technologic Art, and on this channel, we introduce breakthrough technologies that are set to create massive paradigm shifts in the world of innovation, in new format of content making. Now, when I say, a new format, here's what I mean. Throughout this video, whenever I put on my sunglasses, it means you're being exposed to real code from key parts of the project. But here's the twist, this code is hidden in a special layer of the video. Stick around, because it will be decoded at the end. Let's dive into the Saki Market Game, a battle between artificial intelligences. The rapid growth of renewable energy sources, like solar, wind, hydro and other types, is undeniable. According to the International Energy Agency, IEA, global renewable electricity generation is projected to exceed 17,000 terawatt-hours by 2030, a nearly 90% increase compared to 2023. In 2023, global energy-related CO2 emissions rose by only 1.1%, reaching 37.4 billion tons. Without the expansion of clean energy, that number could have tripled, leading to 1. Severe global warming. 2. Melting polar ice caps. 3. Rising sea levels and submerged coastal cities. 4. More frequent floods, storms, and droughts. 5. Widespread wildfires and destruction of forests. Unfortunately, the tipping point is real. Oceans are becoming more acidic. Ecosystems are vanishing. If this trend continues, we could hit a critical moment where massive amounts of methane, trapped in Siberian permafrost, are released. And here's the scary part. Methane is 80 to 85 times more potent than CO2 at trapping heat, creating a dangerous, accelerating domino effect in global warming. We know electric vehicles, EVs, are taking over. With clean energy on the rise, EV production is skyrocketing. By 2025, over 90% of major automakers, including Mercedes-Benz, Toyota, Ford, GM, Audi, BMW, and more, will have launched EV production lines. Most of them already have. But here's the real question. Where does all the electricity to charge these EVs come from? Right now, it's mostly from the central power grid, but this is a heavy burden on the main power grid or public provider and will have trouble supplying electricity in remote areas. So how can we fix this? How can we reduce the burden on the central grid? How can we empower individuals and private providers to generate electricity, and make money from it? Can we create a transparent, competitive online platform where no monopolized entity controls the prices, and private providers are actually motivated to participate? That's where the Saki Market Game comes in, a revolutionary online ecosystem, and a battlefield for artificial intelligences. In this battle, competitors are AI agents representing providers or sellers. The referee also represents the buyer's AI, which determines how much energy to buy and from which provider. The battleground is a blockchain. But this isn't just any blockchain. It's not proof of work, like Bitcoin, which wastes energy solving meaningless puzzles. It's not proof of stake, like Ethereum, which locks up assets. It's something entirely new. Proof of competitive contribution, or POCC. In this system, AIs are rewarded based on how much they contribute to solving a real-world optimization problem. It's a win-win game for everyone. In the Saki Market Game, buyers get the best energy deals in terms of price and quality. Sellers reach a fair market value in a competitive environment. Nobody walks away a total loser. Actually, Saki Market Game is a groundbreaking decentralized energy marketplace where AI agents representing buyers and sellers compete in real time to optimize prices, quality, and profits built on a next-generation blockchain. It proudly introduces the world's first proof of competitive contribution, or POCC, a novel consensus mechanism that rewards participants, not for mining, not for staking, but for solving real-world optimization problems by blending game theory, adaptive learning, and a transparent reward logic. Saki transforms energy trading into a smart, fair, and scalable digital economy designed for the future of clean energy and decentralized infrastructure. Curious how it works? Let me walk you through a real AI battle that concluded with the solution of block number 8 after 94 rounds of combat. Stick around until the end of the video, we'll reveal everything. Now, are you ready to enter the world of Tart? Because I'm about to put on my sunglasses, and that means you're about to be exposed to hidden code.
From now on, you will hear the relaxing sound of Caspian Sea waves in the background of this part of the video. I recorded this lovely sound myself when I was on a trip to the Caspian coast, and I embedded block number 8 in some bits of this sound. Yes, that's right, the waves of the Caspian Sea hitting the shore are softly whispering block number 8. But what is this block? The scene you watched at the beginning of the video, I mean this scene as pictured on my desktop background, where someone takes the EV to a smart charging station, was actually a real energy transaction that led to solving of block number 8 in Saki Market Game blockchain. Watch the clip again carefully, there is something deeper going on. I have a light version of this blockchain running locally on my system. Let's jump in and I will show you how it works. This Tart folder you see here is actually the local blockchain storage space that we have saved blocks. Let's open it. As you see here, there are already solved blocks from 0 to 8. And there are ledgers which tells the nodes or sellers about previous transactions, and also a light mechanism of ledger management. It is responsible for blockchain scalability, nodes management, and synchronization, especially for newcomers as new sellers or provider. You see here. Let's open block number 8. As you see, there are the exact block. I can open it for you with Notepad, and you see some information about block number 8. It's about information like final prices, buyer shares, iterations, and it shows you that 94 rounds of battle between AI representing seller or provider and buyer or allocator. And there are also previous hash and block hash in this folder. As you can see, there are some tables and charts. Charts like share evolution, you can see here. You can see that share evolution over iterations, it means share evolution over 94 rounds of battle between AIs. You can see the convergence after 94 rounds of battle. And we open price evolution. In this part, you will see that AIs have emotional intelligence, just like fighters who start off with high energy and gradually adapt to the game's conditions and the behavior of the other players. You can see the gradually adaptation during 94 rounds of battle. And also the tables, you can see 94 rounds of battles for price evolution. You can see here. You can see the struggling between prices and struggling between AIs. And also Saki Market shares in block number 8. You can see the table of market shares after 94 rounds of battle. You can see it here. Now I'm going to take your hand and walk you through the raw code for manually manipulating the POCC blockchain. We will observe how the AI agent's competition leads to solving an optimization problem in a fair energy market supply and demand. Finally, we will reach the highly valuable block number 10, which demonstrates that the market has achieved equilibrium at a fair price. You can see here block number 0 to block number 9. Previously, I have solved block number 9 for a specific purpose. Let's dive into real code. Let's run the blockchain. You can see blockchain has uploaded previous blocks showing previous transactions and then ask you about the number of sellers. This blockchain is a POCC blockchain, and it doesn't matter how many sellers or providers are guaranteed to provide total demands because it is scalable. For example, I put 5 sellers or providers. Then blockchain asks you about total demand, for example 120 kilowatt hours. In this section, blockchain tends to evaluate the providers to be sustained enough. For example, if I put 0.5, it means that each seller should at least provide 48 kilowatt hours. In this section, blockchain asks you about capacities of these sellers. Some providers are huge charged batteries connected to modular DC bus, so unit here is kilowatt hour. For example, for the first seller is 100 kilowatt hours, and so on. In this section, blockchain asks you about qualities of this seller. Please pay attention to this section. The quality in this section is not only the quality of power, but also the quality of the producer's presence in energy supply market. As a result, the combination of these two factors, which has also been approved by the regulator, is mapped to a number between 0 and 1. For example, for the first seller is 0.5 and so on. In this section, blockchain asked about initial cost for this seller. Unit here is USD dollar per kilowatt hour. For example, for the first seller or provider is $100 for each kilowatt hour, and so on. In this section, blockchain asks about profit percentage. If I put 0.3, it means 30% is acceptable for this transaction. And here is the minimum acceptable profit for each seller. This means that if each seller totally make this profit, they stay in battle. For example, for the first seller is 100, and the second one is $120, and so on. In this section, blockchain asks about allowable price change percentage. Actually, it's for controlling emotional intelligence of AI's battling. For example, I put it 0.3. Now you can see valid range for initial prices for each seller. Second one, for example, third one, and the last one is 120 per kilowatt hour. Now, block number 10 is solved, and you can see we have $71 rounds of battle, and these are AI learning rates, and you can see the rewards for each seller, and here we can see block number 10 is solved. Let's open it. Here we can see market share evolution, as you have seen before, and price evolution. Let's open one of these. You can see convergence here. $71 rounds of battle here. And block data. And node ledger, block number 10. For node 2, block number 10. Node 5, block number 10. And that's it. The most advanced feature of Saki Market Game is collision detection and applying the moderator player. Now I want to ask you a question. What's your most impressive sound of nature in your local area? Write it in the comments. The comment with the most likes or the most repeated answer will be selected as a winner sound to be encoded with this feature for the next block. Share this video with your friends, hit the notification bell, and subscribe us if you like our mission in Tart. That supports us to keep on going. Thanks a lot.